All right, in this lesson, we're going to focus on triangle sums. So we're going to start learning about congruence in terms of, I guess, the transition from rigid transformations into working with triangles and focusing mostly on the congruence piece of it. So triangle sums, we're going to start this first section by focusing on understanding and being able to apply the triangle sum theorem, identifying interior and exterior angles in a triangle, and then also by the end of this lesson, you should be able to, you hopefully understand the exterior angle sum theorem. So two big things here. We have understanding and applying the triangle sum theorem, and then we also have understanding and applying the exterior angle theorem. The definition of a triangle, if you look at this one here, it says that a triangle is three segments joined at three non-collinear points. So what does that mean? Three non-collinear points, so 3 points that are not on a line. And then those are your three endpoints. Those 3 points are also known as vertices. So each one individually is called a vertex. And then you have your three sides. The three sides are going to be line segments. And then when you have two sides that are put together like this, those two sides are known as adjacent. So if I was to grab this angle up here and then put these two sides together, then these two sides would be called adjacent to each other. We're going to name these triangles, so I'm going to give you a couple different methods for naming different triangles. This first one here, these first three, I guess, are going to be based off of naming by sides. And then the next ones, I'll talk about how to name the triangles based off of their angles. This triangle here, all three sides are congruent. That's what those little tick marks mean. So when all three sides are congruent, the triangle is known as equilateral. On a triangle, when you have two sides that are congruent, then the triangle is known as isosceles. And then on a triangle, when you have no sides that are congruent, the triangle is known as scalene. So types of triangles by sides, all of them are congruent, equilateral, two congruent, isosceles, none of them congruent, scalene. Now if we name them based on the angles, when all of your angles are less than 90 degrees, when all of them are less than 90, they're known as acute. When one of your angles, when at least one angle is greater than 90 degrees. So if one angle is greater than 90 degrees, the triangle is known as obtuse. So in this triangle here, this angle is clearly greater than 90 degrees. And then these two angles are smaller than 90 degrees, so it is known as obtuse. And then when one angle equals 90 degrees, the triangle is known as a right triangle. So this little corner down here looks like your 90-degree angle, so we put a box in there to symbolize that it's a 90-degree angle. So this triangle here is known as a right triangle. So how do we classify triangles? The sides, scalene, isosceles, and equilateral. If it's by angles, it's acute, right, and obtuse. Now there's also another name. There's one called equiangular. An equiangular is also is a triangle when all three of these angles are all congruent to each other. Now an angular triangle will also be equilateral. An equilateral triangle means all three of your sides are congruent. Equiangular means that all three of your angles are congruent. Now in interior angles versus exterior angles. We're going through a lot of vocab here. So the interior angles are going to be this A, B, and C. They're the ones that are on the inside of your triangle. Now, if I was to take my line segments and I was to extend them outward, taking a look at angle A. Angle A has an angle has another angle that makes it 180 degrees. A is on the interior, M is on the exterior. But when I take those two angles, they add up to 180. They form this straight line. So your exterior angles are going to be the ones that lie on the exterior of your triangle. So M, P, and N, all three of those angles are exterior angles. If you were to take a triangle and rip these three corners apart. So let me show you the next slide real quick. If I rip those three corners apart, and I take the three corners and I put them together. When I put them together, hopefully you notice that they make this straight line. A straight line is equivalent to 180 degrees. So what that tells me is I can kind of deduce that on a triangle, when I add up interior angles, the three interior angles, the measurement of the three interior angles, when I add them together, it's going to equal 180 degrees. And that is known as your triangle sum theorem. So the triangle sum theorem simply states that when you add up the three interior angles on a triangle, they will always add up to 180 degrees. Now, because when I add up the three interior angles, since they equal 180 degrees, I can now utilize some of my algebra skills to help me figure out what some of these angles are equal to. So on this triangle here, I know that if I take 110 and I add it to 25 and I add that to x, I know that that's going to equal 180 degrees. And that's because of the triangle sum theorem. So now once I have this equation set up, now I can go through and I can simplify and solve it. So 110 plus 25, 110 plus 25 would give me 135 plus x equals 180. Subtract the 135 from both sides, and we find out that x is equal to 45 degrees. So x is 45 degrees. Find the measure of each angle. Again, the triangle sum theorem tells us that if I take all of the interior angles and add them together, that those angles are going to equal 180 degrees. So now that I have my equation set up, I can go through my steps where I simplify and solve. So 2x plus x, those are all like terms. They're on the same side of the equal sign. So just combine your like terms together. 2, 3, 4. So 4x, and then 10 plus 2 gives me plus 12 equals 180. So 4x plus 12 equals 180. Subtract the 12 from both sides. Your 12 is gone, and you end up with 4x equal to 178. Excuse me, 168. Now divide both sides by 4, and you get x equal to 42. Now because this represents our x, take a look back at what they're asking you for. If they're asking for the measure of each angle, if they're not asking for x, then make sure you actually identify. This angle down here is equal to 42 degrees. This angle up here would equal 84 plus 10, 94 degrees. And this angle over here would equal 44 degrees. Now when you identify the measure of your angles, don't forget to include your degree symbol to represent that that is the angle measure. And now taking a look at the exterior angles. When you're working with exterior angles, if you go back to that picture where we ripped apart the corners. So I'm going to jump back to that slide real quick. Let's say that this was A, this was B, and this was C. This angle C, if I was to remove these two pieces, I'm going to call this angle, let's call this angle M, capital M. When I remove those two pieces, capital M is the exterior angle of angle C. So an exterior angle M would equal A plus B. If I was to take these two pieces of paper and add them together, those would equal this exterior angle. And that leads us to our exterior angle theorem. The exterior angle theorem states that anytime you have an exterior angle, it is equal to the sum of the other two angles. So the measure of an exterior angle equals the measure of the two non-adjacent interior angles. And what that simply means is the measurement of this exterior angle will equal the sum of the other two angles. So given that angle A is 50 degrees, angle B is 34 degrees, then what is the measurement of BCD? In other words, this exterior angle out here. The measurement of angle BCD, since that's an exterior angle, it is equal to the sum of these other two angles. So the sum of the other two angles, 5, 6, 7, 8, would be 84 degrees. This exterior angle is 84 degrees, even though it doesn't look like it. The drawing is definitely not drawn to scale. What is the measure of angle ACB? ACB. We can figure out what this angle is equal to by either taking 180 degrees minus 84, or if you think of your triangle sum, 180 minus 50 minus 34. So we find out that this angle here, 180 minus 84, that comes out to 96. So again, even though it doesn't look like it, that angle would have to equal 96 degrees. Solve for x. X is an exterior angle, so therefore I know that it's going to equal the sum of the other two angles. So those other two angles, 79 plus 14. So according to this, according to these numbers, x here, this angle is 93 degrees. Now the corollary for the fact that interior angles add up to 180. The acute angles of a right triangle are complementary. So what does that mean? What that tells us is that when I have a right triangle, I know that this angle down here in the corner is going to be 90 degrees. Well, that tells me that these other two angles have to add up to 90 degrees. That's all that this is saying. So if you have a right triangle, these two angles are going to add up to 90 degrees. And that's because if I take 90 plus 90, I'm going to end up with 180. Given the following triangle, what is the length of the hypotenuse? Now this is a right triangle. On a right triangle, the two sides that make up the 90-degree angle are called the legs. The side opposite the 90-degree angle is called your hypotenuse. So given the following triangle, what is the length of the hypotenuse? Well, that would equal 13. What are the length of the legs? The legs are 12 and 5. If one of the acute angle measures is 32 degrees, what is the other acute angle's measurement? So let's say that this one up here was 32. It's asking what the angle down here would equal. Now, because this is a right triangle, you don't have to think of it like this, but because this is a right triangle, I know that these two angles have to add up to 90. So 32 plus some number has to add up to 90. Like I said, you don't have to think of it that way because you could just say 90 plus 32 plus that unknown corner is going to add up to 180. These two statements are basically the exact same thing because if I got rid of 90 from here and 90 from here, I have this equation. So what does that unknown angle equal? Well, I would have to subtract the 32 from both sides. 90 minus 32, so 9, 8, 7, 6, 5, 8, 58 degrees. find the missing measurements. All right, so if this corner down here, if we think about the what we've been working with, this here is an exterior angle, which means that these two angles have to add up to that exterior angle. So this drawing, this picture, it's showing me that if I take 53 and I add it to that missing angle, it has to equal the exterior angle. 53 plus what equals 80? I'm going to subtract 53 from both sides, and I end up getting 27 degrees. So this missing corner here is 27 degrees. Let's walk through this one. So if I know that triangle ABC has a measurement where angle C, the measurement of angle C is equal to 90 degrees. So the measurement of angle C equals 90 degrees. Well, that's given to us. We know that. Well, now if I go to number 2 and I try to say A plus B plus C, the measurement of A plus the measurement of B plus the measurement of C equals 180. Well, what allows me to make that statement? Well, the fact that it's a triangle allows me to make that statement. So this is the triangle sum theorem. The triangle sum theorem allows me to make this statement number 2. Well, what allows me to make statement number 3, the logical thought process? All I did was remove this and replaced it with a 90. So all I did there was substitution. Well, after I substituted, well, now I subtracted the 90 from both sides. So when I went from step 3 to step 4, what allowed me to do that? Well, the subtraction property of equality. And we were asked to prove that those two angles add up to 90, and that's what we got to down in step 4. So since we got to that step and we walked through and specifically stated specific definitions as to why each step happens, we can now stop at step 4 because we just proved that the measurement of angle A plus the measurement of angle B would equal 90 degrees. All right. So like I said, by the end of this lesson here, you should have an understanding of how to apply the triangle sum theorem. You should be able to identify interior and exterior angles in a triangle, and then you should be able to understand the exterior angle theorem.